So this is exercise 7.3.27, where you're told that you receive a brochure from a large university. The brochure indicates that the mean class size for full-time faculty is fewer than 32 students. You want to test this claim. You randomly select 18 classes taught by full-time faculty and determine the class size of each. The results are shown in the table below. At a level of significance of 0.10, can you support the university's claim? Complete parts A through D below. Assume the population is normally distributed. So the claim that is made is that the mean class size is fewer than 32 students, and you therefore believe that it's actually greater than or equal to 32 students, which is why the appropriate null and alternative hypothesis would be what we see in F. The claim is that mu is less than 32, and you believe that mu is greater than or equal to 32. So now the question is, how do we go about testing this claim? Well, we've got to take these values, these numbers of class sizes, and we've got to put them in our calculator. Looks like. There it is. Okay? So now the question is, how do I go about determining the p-value? Well, because in our alternative hypothesis we said that we believe that it's actually greater than 32, we've got to find our area above that t-test statistic. So we'll choose our tcdf command on our calculator, which is under the distributions menu, second vars. The lower boundary is negative 1.02. The upper boundary is positive infinity, a really large number, or 1 times 10 to the 99th power. And then we have to give our degrees of freedom, which is 1 fewer than the sample size. Sorry, I misspoke. I'm looking for, in this t-distribution, the null hypothesis said that it was less than 32. So we've got to take our test statistic of negative 1.02 and find the probability that it is less than. So instead, we've got to take the area in our lower tail, which would be negative infinity, or negative something like 10,000. Our upper area, or upper value, would be our test statistic, negative 1.02, and then our degrees of freedom. So this would be negative infinity, like negative 10,000, to our test statistic, negative 1.02, with 17 degrees of freedom. And when we do that, we get a p-value, area in the tail, of 0.1610. Therefore, we have a large p-value. It's not smaller than our level of significance given of 0.10, so we fail to reject the null hypothesis. When p is low, we reject the whole. Here, p is not low because it's not less than the level of significance given of 0.10. Therefore, we fail to reject the null. So I see an x bar of 30.6 repeating. I see an S of 5.5412888871. So these are the two values I'm interested in computing my t-test statistic. So to find my t, I take my sample average minus my claimed population average, and I divide by the standard error of my mean. Now if I'm going to enter this in my calculator in one command, I've got to make sure I enclose the numerator and the denominator in parentheses. So my sample average is 30 0.667. I'll just round. My claimed average is 32, so I've enclosed that in parentheses. My S is my S of X, 5.541288871, and I'm going to divide that by the square root of my sample size, which is 18. And when I do that, I get my test statistic, which is my t-test statistic. That should come out equal to about negative 1.02. So I'm about 1.02 standard deviations below the mean. Let me show you what that screen is. List 1, I put all of my values that were given in that data set. I got to this list by hitting Stat, Enter, which is option 1, and I just plugged in those numbers that I have entered here in L1. So then I need a mean, I need a sample mean, I need a sample standard deviation, and I know, of course, that n is 18. So I went ahead and I did stat calculate one variable statistics, and I hit enter, and it gives me the following screen.